And welcome students to our first lesson in binary and hexadecimal. Today we'll be talking about a quick introduction into what binary is. So let's first ask the question of what is binary? Well, we've actually already introduced the concept and the idea of binary, or the representation of two states using either a 0 or 1. Now, binary of course can represent anything from text to computer instructions, or any other data that the computer really uses, using a series of zeros and ones. And if you recall earlier, we had talked about how those zeros and ones are really a voltage state. Zero is low voltage, one's high voltage. Zero usually is like the quote-unquote off state, and whereas one is a quote-unquote on state. Now, binary is base 2 instead of base 10 that we traditionally use in decimal. For those of you might be familiar with logarithms, this might be familiar to you, but we're not going to worry really too much about logarithms, so you don't have to worry about that too much here. But just know that binary focuses on base 2, and decimal, which is what we usually use, 1, 2, 3, 4, 5, 6, 7, 8, 9, that sort of thing, that's base 10, because we go from 0 to 9. Binary is just 0 to 1. All right, so let's just go through a few examples here to kind of warm us up into it. Let's start by talking about binary of one place value. So as I mentioned, binary is either 0 or 1. In decimals, we have the values 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 as the choices for the ones place. So I can either have 0 all the way up to 9. Now, binary, I can only have 0 to 1. Decimal, I have 0 to 9. So our options are limited. We can either only have 0, which is the same as 0 in decimal, or we can have 1, which is the same as 1 in decimal. Let's expand this though now to go to two place values. All right, in decimal, the second place value is familiar tens place. However, binary does not have the tens place, rather binary is constructed using powers of 2. So the ones place was the same thing as 2 to the power of 0, or 10 to the power of 0. All right, so here we're going to actually use 2 to the power of 1, and because we're using 2 to the power of 1, we have these two places, and we can have four possible values. We can have 0, 0, which is still just 0. We can have 0, 1, which is still just 1. We can have 1, 0, which is 2 in decimal. And I can have 1, 1, which is 3 in decimal. You don't have to worry too much for this lesson about the conversion stuff. We'll talk about how to convert into decimal later on. But right now, let's just focus on this kind of concept of how binary is constructed. All right. Binary of multiple place values. All right. Like I already mentioned, it uses powers of 2 to represent its place. So 2 to the power of 0, 2 to the power of 1. You can kind of figure, from there it would be 2 to 2, 2 to 3. It just goes on, so on and so forth. This pattern continues. However, in computer science, we often don't look at anything past 8 digits. Right? And the reason for that, if you remember, each of those digits is one bit of information. Each bit is a 0 or 1. And if we have 8 bits, we construct 1 byte. So the max value, therefore, in binary is typically 255. So if you were to take and put a string of 8 bits out, all ones, you'd have 255 if you were to add everything up. The minimum value is 0. Now, a quick side note here is that this is only true with what's called unsigned values. With signed numbers, the range changes from negative 127 to positive 127. As you know, 0 to 255 doesn't deal with negatives. If we want negatives, we have to get into signed numbers. So let's talk about those unsigned binary and how to write them. Now, since we know that 8 bits construct one single byte, we typically write a binary string with 8 digits, filling in zeros for that value. So if there is not a number there, so like in this one right here, I have 0, 0, 0, 0, 0, 0, right? Which is the equivalent of 0 in a decimal format. However, here, because we're getting used to using binary, if there is not a value there, I'm not just going to put 0. I want to put a series of zeros. So each one of those 8 place values has to be filled in. If there's not a number that goes there, put a 0 there. All right. Now notice how the space is also added between each set of 4 digits. All right. This is very similar to how we use a comma for every 3 digits in decimal. It's just a spacing thing that kind of makes it a little visually nicer for us to try and read. Doesn't make it as congested. Now, if we continue talking about these unsigned bits, let's see if we can try to crack what these are in decimal. And you're not going to be assessed on this in this lesson. This is just kind of see if you can kind of understand how some of this stuff works. So let's see if you can think what these might be with their decimal equivalent. So here I have 0, 0, 0, 0, 0, 1. Well, the equivalent of that is 1 because there's just one place value there. Here I have 0, 0, 0, 1, 0, 0, 0. The equivalent of this in decimal would be 8. And here, 0, 0, 0, 1, 0, 1, 0, the decimal equivalent is 10. Finally, we have 0, 0, 1, 0, 0, 0, 0, 1, 0. Now, we haven't really talked about this half right here, but this is, again, still powers of 2. And if you know your powers of 2, this is 2 to the 0, 2 to the 1, 2 to 2, 2 to 3, 2 to 4, it's 2 to 5, so that's 32 plus 2, which is, or 32, yes, plus 2 is 34. All right, now, let's look at signed decimals. All right, so signed binary bits. All right, we're going to just really quickly talk about these. The first digit in a signed binary bit will determine if the value is a positive or a negative. The other 7 digits comprise the number, so that's why we can only go up to the positive and negative 127. If the first digit is 0, then the number is going to be a positive. If the first digit is a 1, then the number is a negative. So, quick examples. A positive 0, 0, 0, 0, 1, 0, 0, that's a 4 in decimal. And then a negative 1, 0, 0, 0, 0, 1, 0, 0 is a negative 4 in decimal. So notice that the other 7 digits are exactly the same. What changes it was that first digit. All right, and let's just quickly just look at a couple of these. All right, that should say signed there. I'll have it fixed in here in a second. Can you figure out what these numbers are in signed form? All right, so here's some signed ones. This first one, you'll notice, is a 1, but we have this 1 in front, and because we're dealing with signed binary bits, it changed that from 1 to negative 1. All right, similarly here, this one looks familiar, all right, and you notice that we have a 0 in front, which means that this is 8. Here I have a 1 in front, which means this becomes a negative, and this one is a positive because of the 0. This right here, of course, would then be a negative 10, and this right here is a positive 34. Okay. And just to conclude, folks, for this lesson, if you're wondering how am I going to know whether this is a signed or unsigned value, it will say in the homework directions whether you're dealing with signed or unsigned digits. So if you're having a freak out wondering, is this signed, is it unsigned, which way am I going to have to look this? Again, that will be directed to you saying that this is going to be signed or unsigned. If it does not say specifically within the directions, assume that it will be unsigned. Until next time, ladies and gentlemen.